Okay, so today we're going to be going over lattice multiplication. This is an algorithm that is newer. It didn't exist when a lot of the parents were kids, and so a lot of parents don't understand it. However, it organizes the numbers in a way that makes sense to a lot of students and eliminates some of the mistakes that exist with the traditional algorithm. So looking at this 2 by 2 problem here, I'm going to start by, let's say I wanted to do 7 times 3. I would only need one box because this is one digit by one digit. So the 7 would go on top. I'd put a times sign at the corner, and a 3 would go down the side. And 7 times 3 is 21. So I would fill in my number into the triangles with one digit in each triangle. Now let's say I had something that yielded a one-digit answer, like 3 times 2. 3 times 2 is 6, so I would have to fill it in as 06. So here I've got a 2 by 2 problem though. That means I need two boxes across the top because 85 is a two-digit number. So 8 goes on that box, 5 goes on that box, my times goes in the corner. Now going down the side, I want to put 74, so one box would not be enough, so I would need to draw two more boxes. Now my suggestion to you is that you can either use the sheet that I will attach to the lesson that already has all of the lattices drawn, or using graph paper. You can easily draw a square around the boxes that you need, and then you can draw your diagonals. Now the diagonals must poke through the corners, because you will see in just a moment if they don't poke through the corners, you will end up adding up the wrong numbers. So I'm going to do 85 times 74. So I'm going to cover up the bottom. I want to start by multiplying by the digit on the top, and on the right side is a 7. I don't want to accidentally put the answers in the wrong place, so you might want to use a sheet of paper or an index card to cover up the bottom of the grid so that you don't put them in the wrong place. So I'm going to do side times top and drop. So 7 times 5 is 35. So underneath this 5, I'm going to put the 35. Then 7 times 8 is 56. So I'm going to fill in the 56 right there. Now I'm going to go ahead and move my card so that I can see the bottom. So now I'm going to be doing 4 times the top and drop. So 4 times 5 is 20, and 4 times 8 is 32. So now I'm going to remove my card. Now, a lot of people think, oh, this is so bizarre, but we have basically done what you do with the traditional algorithm. This will be my ones place digit. This is going to add up to my tens place digit. This is going to add up to my hundreds digit. And this is going to add up to my thousands place digit. So it's organizing it in a very similar way. Now the benefit to this over traditional is when you're doing traditional and you move over to the tens place and so on as you multiply, you have to remember to put a 0 before you start multiplying. Also, when you start carrying those numbers and stuff up top, it can get really messy, and sometimes you forget to add one of the numbers, and that can cause a lot of problems. So starting here in my lattice, the first digit will always be whatever's in that first triangle because there is nothing to add it to. So the first digit's going to be a 0. Now my second digit, I'm going to need to add everything that is in this diagonal column. So 5 plus 2 is 7, and 7 plus 2 is 9. So my tens place digit will be a 9. Now in this next column here, I'm going to need to add up all these. So 3 plus 6 is 9, and 9 plus 3 is 12. Now I cannot put two digits here. So I'm going to take that 1, and it's going to be carried into the next grouping. And put it inside the triangle. Don't put it outside because you might forget to add it. So this is gone, and I have moved it over here, and 5 plus 1 is 6. So my answer is going to be 6,290. Okay, so we're going to do one more problem with the lattice multiplication in this video here, and then you can go do some practice on your own. So we're doing 786 times 24, which this time we have a 3-digit number, so we need 3 boxes going across the top of our lattice. So the 7 goes on the first column, the 8 goes on the next column, and the 6 goes on the next column. Times goes in the corner, and then the 24 is going to go underneath that. Now, once again, while you're beginning, you may want to cover up the bottom. That makes sure that you get the correct products into the correct boxes and don't flip-flop multiplying by the 2 and multiplying by the 4. So we're going to start with 2 times 6, which is 12. So we put 1, 2 in the first 2 triangles. Then 2 times 8 is 16, and 2 times 7 is 14. Okay, so moving down here, 4 times 6 is 24, 4 times 8 is 32, and 4 times 7 is 28. So I'm going to be adding up the numbers diagonally. So first of all here, the only thing that is going to the right of that diagonal is the 4. And whatever is in that first triangle is always your ones digit. Now going to my next column, pick out a highlighter here, I'm adding those 3 triangles together because they are between the 2 diagonal lines. So I'm doing 2 plus 2 plus 2, and that is a total of 6. Now when I get to my next column, I've got quite a few numbers to add up. So 8 plus 3 is 11. 11 plus 6 is 17, and 17 plus 1 is 18. So I put the 8, and then the 1 cannot go in that parking spot because there's only space for 1. So the 1 from the 18 is going to be carried into the next grouping of triangles. So do not put it outside the triangles, make sure it goes inside. Now that does not make that an 11. That's a 1 and another 1 beside it. So 1 plus 1 is 2, 2 plus 4 is 6, and 6 plus 2 is 8. And then here, 1 plus nothing is just 1. Now my answer is in the parking lot. So these little diagonal spaces here, that's my parking lot. So my answer on this one is 18,864.